So good morning, everyone. It is a special pleasure for me to present you this topic today in this session. Throughout the conference, I've noticed, and probably you also noticed, that this kind of applications turn out to be very, very interesting for researchers, and it is a great pleasure to have this topic continued in our session too. So one of the examples of application of LiDAR scanning, TLC scanning, is also our case study in Serbia. And on behalf of our young team and our young project, I will present you this topic today. This is just the presentation outline. The focus will be on the study site, which is located in Serbia. So first about some motives and objectives that we have with terrestrial laser scanning. What are the motives? Why are we using it, and why is it so popular? Well, first of all, there are a lot of challenges for conventional mapping of rock slopes, and the biggest one is actually the problem with the inaccessible parts of the slope. Some parts are usually too high or too steep to reach, and this is where we have our approximations, and the uncertainty. We introduce a lot of uncertainty there. On the other hand, it is also very difficult to have accurate measurements with the tools that we are conventionally using, like geological compasses and measuring tapes. So the precision is maybe not, it is probably outdated, and the demands of present-day design are greater than that. So what TLC is offering are benefits, and first of all, the benefits of unprecedented precision and accuracy, and second of all, it enables the inaccessible parts to be scanned. It offers a digital format for all of that, so that we can reuse the data anytime we want, and what is more important, especially for monitoring, we can track the changes that happen throughout the time. So this has been recognized also by the producers and manufacturers of the TLC systems, and they are also trying to bring this technology closer to us, and here I have one example. I hope it will work. Where you can use a simple web browser like Internet Explorer with some plugin and go through your point cloud. This is another case study. This is not the one that I will present today, but this is actually a point cloud in a web browser. So you can perform also measurements. You can define X, Y, Z points, any point on the, okay, these are relative coordinates of the local coordinate system of the scanner, but you can also georeference the point cloud and get the data, the actual coordinates of every point. You can measure distances as well, so joint spacing, and for example, this is 3 meters, for example. So it's a promising technology, and it's a revolution in, I would say, in geological engineering applications. Just a few words about the general working principle of TLC system. It basically measures the time. So the time between the emission and the reflection of the signal of the object, and it calculates the distance based on that time difference. By reconstructing all the differences in the space, we can reconstruct the geometry of that space. So each point will get X, Y, Z coordinate of local or global reference system. And also in some systems it is possible to get the intensity of the signal, and also the natural color values, RGB values of the signal, which is sometimes also very useful.